Hi guys, I'm back with analogy of chemical elements with human. I don't know who follows who, whether it is chemical or chemical following human or human following chemical. It's your guess. Alright, so let's get into it. We missed out twin elements in our last periodic table video. Now here when you see yttrium and lanthanides, they are not twin elements, but after that 4th, 5th, 6th, 7th group have twin element and they are zirconium, hafnium, niobium, tantalum, molybdenum, tungsten, technetium and rhenium. These are to be by-hearted as it is. Let's get into periodic table. Now, as an example, I am picking up electropositivity and electronegativity in periodic table. And the elements that I choose for explanation is alkali and alkaline elements and halogens for better understanding. Now, when we speak about alkali and alkaline elements, they tend to lose 1 or 2 electrons respectively. Why? These elements tend to lose 1 to 2 electrons only to gain stable configuration of inert elements. Alright. When we come to electronegative element, they gain 1 electron. Why? To gain configuration of inert elements again. Now, when we talk in terms of electropositive element, what we observe is that these elements lose electron and they get configuration of elements which belong to a period above. Alright. For example, if I take lithium, lithium loses 1 electron. Alright, lithium belongs to period 2. But the configuration that it gets is of period 1. Alright. Now, when we come to electronegative elements, what we find is as they gain 1 electron, like take for example fluorine. Fluorine belongs to period 2. Alright. Now it gains 1 electron and gets the configuration of neon. And neon also belongs to period 2. So the conclusion that I draw from this is, and at the same time, sodium, alkali and alkaline element loses just 1 or 2 electrons, whereas halogen gains 1 electron for the same purpose. How do I find that it is analogic to our lifestyle? See, we also looking for stability in life. Alright. Now, electropositive element jumped from this period to above period. Alright, this is as good as for stability. It's as good as we people migrating to other states or other countries for stability. Alright. Then, in case of electronegative elements, they just gain 1 electron and were in the same period. So it is just like those lucky ones, those who get opportunity in their own vicinity. Alright, so they don't have to go to period above. They stay in the same period, in the same vicinity and gain stability. Then again, when we go to halogens, they just take 1 electron. Alright. Whereas when we go to alkaline elements, they lose 1 or 2 electrons. And as we go across like that, we'll find they will be keeping on losing more and more electron. As we come towards electronegative group, as we come towards 17th group, we will find that they will keep on rather gaining. These would lose, these would gain. How do I analyze, how do I put analogy here? Now, when a person is migrating to upper period, I am talking in terms of alkali and alkaline elements. When they are migrating to upper period, what happens? Now, people think of those who are migrating from their location to some other location. Alright, while doing this migration, they are losing all the environment. They are losing their ties, family ties, they are losing their friends for the sake of stability. Whereas these are the lucky ones. They are not only in their location, but they also gain electron, or rather they also gain lots of perks and lots of and towards the stability. So I would say that these halogen type of people or electronegative type of people are the chosen ones. They don't have to migrate. At the same time, they get in electrons, so they get in more perks and all towards stability. Whereas these are the people, poor people, they have got to migrate to some other state, other country for stability, and they also lose relationships. All right, so that's what I think about. All right, now let's talk in terms of electron gain enthalpy. Now we know that electron gain enthalpy, whenever an electron is being gained by an atom, it loses energy. All right, electron gain enthalpy, I just say it's marriage. When an electron gets into the shell, now again halogen, I've chosen halogen so that it becomes very easy for me to make you all understand, make you all get my concepts. All right, very selfish, right? Okay, anyways, so halogens, so what happens is halogens already have 7 electrons in their valence shell. So to accommodate one more, there is intra-electronic repulsion. To accommodate one more, they have to shell out energy so that the 8th electron which has been taken in gets its place. It's just like marriage. Now when a girl leaves the family, now if you're talking in terms of sodium chloride, so this 1 electron which is there has left its family, there is sodium, valence shell of sodium, and come into this family. Adjustments are required. You have to shelve out some energy within yourself, all right, in your vicinity. Shelve out some energy, some excitement, and all those things. You have got to keep it aside because you have got to adjust that 1 electron in the valence shell. So electron gain enthalpy, and when you do that, stability is attained. All right, it is good for the family, it is good for the atom. All right, so electron gain enthalpy is that adjustment which the family does when daughter-in-law gets in to the family. All right, so that's what I feel. All right, now let's get into ionization potential. As we go across the period, nuclear hold on valence shell increases, as a result of which the atomic size decreases. Now this is the theory, but now I am taking out my contentions from this. All right, now so what happens is, obviously when we are going across the period, number of electrons in valence shell is increasing. So this I call in terms of richness of electron. Ionization potential keeps on increasing, all right, across the period. So now here, electropositive, poor, electronegative, rich. Now we always see that poor, they don't mind much losing because they feel that, oh, I didn't have anything, so even if I lose this, there won't be much of difference. Whereas rich, when you come here towards electronegative elements, ionization potential is very high. So energy required to strip electron is very high. So it is rich. Rich, those who are rich, you will find that many of them are very miser. In spite of having so much of fund, still they would feel a bit, if they lose a bit, they would feel bad about it. I'm not saying about all rich people, right? It's just normal observation. So the hold IP on electron, lots of electron is too much. So to take out money from there for whatever charity or whatever, is difficult. So ionization potential high with riches and ionization low with poor. That's what I feel. All right, maybe you have different opinion about it, but that's what I feel. That's what I've seen. Richer, miser. Whereas poor, they feel, oh God, I didn't have. So it doesn't make much of difference. All right. So that's what is life. Now let's get into bond formation. All right. That's also, I try to make it very interesting. Let's see how it goes with you all. Electrostatic bond, ionic bond. All right. In case of ionic bond, what happens is, let's take sodium chloride as an example. Please pardon me, I'm taking sodium chloride as an example because that helps my purpose. All right. So sodium tends to lose one electron, it loses one electron. Cl needs one electron to complete its octet, so it gains that one electron from sodium, and this is satisfied with its octet, with its inert configuration. Sodium is satisfied with its inert configuration, but at the same time sodium gets positive charge, Cl gets negative charge, and then their electrostatic attraction. Fine, very good. The romance that we see in today's many of these youngsters, we find that infatuation there, right? So positive, negative gets attracted, electrostatic attraction, and ionic bond. All right, there's an ionic bond formed, and we feel that this is very strong bond. But as soon as put to test, dissociates. Take sodium chloride, put it in water, it dissociates into Na plus Cl minus. All right, so the bond is broken. So this is what I say is what I see and I say about today's generation. Lots of such kids, they get infatuated and they waver away from their studies and get into this romantic ties, and then it breaks up. It very readily breaks up. So sad. All right, so this is what is ionic bond. Now let's get into covalent bond. Now let's take methane as an example. So methane, in case of methane, carbon CH4, carbon has got 4 electron in its valence shell, requires 4 more electron to complete its octet gain in that configuration, right? So it chooses 1, 2, 3, 4 hydrogen and forms methane, octet complete. The bond is very strong. Put into test, it's really strong bond, covalent bond. Now this is what I call as true love. So now you would say that 4 hydrogen, so does that mean 4 love stories? I say no, it is varieties of compromises, adjustments that a person has to do. 4 bonds, say 4 adjustments a person has to do for stable life, for stability. All right, so number of bonds, number of adjustments to be done in life for our compromises, adjustments to gain stability in life. Then there are certain type of people, like they are initially confused about their love story. They get into that love story and then they are a bit confused, but then over a period of time they gain that stability, they gain that maturity, they gain stability, and lifelong they stay together. Now this is an example of polarization. Now if I talk in terms of lithium, now lithium does that. What it does, it gives its electron to chlorine. Okay, so it becomes Cl minus Li plus. So initially it forms that sort of bond, infatuation sort of bond, ionic bond. But then what it does, it pulls the electron pair towards itself. That is polarization, and gets converted to covalent bond. So that ionic bond which was there initially now gets converted into covalent bond, stability. So all those ionic love stories are not failure. Now lithium chloride is an example where it starts with electrostatic attraction, as I mentioned earlier, but then proper adjustments, proper compromise, proper situation tackling forms a stable covalent bond. So we also find such sort of people in our life. I can go on and on like this, but I would like to culminate in coordination, covalent or dative bond. That's very interesting. Now what happens in case of coordination, covalent bond or dative bond? You have an acceptor, you have a donor. Alright, so donor is donating electron pair to the acceptor. Alright, now when it donates, now this becomes again a sort of coordinate bond, a covalent bond. Alright, now a covalent bond. Now this donation now goes into sp-d orbitals. Alright, so it goes towards interior core, even to d orbitals. Alright, so it forms complex. Now this complex, these coordination compounds are the most stable compounds. The relationship is between acceptor and donor. Okay, donor and acceptor. So you can obviously correlate it with one-sided love. Alright, so one-sided love given, and then it becomes very strong over a period. In coordination bonds also we find coordination number to be 2, 4, 6, so on and so forth. Now what are those? Those are all adjustments. Those are all number of adjustments a person does to make life stable. So obviously even the elements follow that system of adjustment, compromise, more number of adjustment, more number of compromise, and getting for the sake of getting stability. All right. A coordination compound reminds me of a case wherein a guy used to love a girl through his heart, like anything. But this girl was more towards career. So he proposes this girl, but this girl flatly refuses, saying that she was married to career. Alright, so but this guy pursues her. He's very confident about himself, and he was also confident that he would be able to convince her. So he does. So he convinces and gets married. But he never forgets throughout life that she already had declared that she was married to career. Now they have been together for 4 decades. But what I found is most of the time it was this guy who kept on sacrifice. He never thought, why me? Why? Because he always kept in forefront married to career, wife's statement. All right. And keeping that in mind, wherever he thought that he could support her, he supported. And what was the result? The result was she really prospered at corporate level. And obviously prosperity at corporate level, lots of fund and stability of house. So just like metal complex, ligands, one-sided love, donating lone pair, and metal providing stability. So this story, I just felt like talking to. Now it's 4 decades that they're together, and they are saying, oh God, time has passed, days are over, now we have only few days left. So time is very cruel. So please always think of covalent bond. If ionic, then polarized, and coordination bond. I don't say that it has to be one-sided love. It was just an example of a coordination compound. Alright, so worth thinking, right? So life is not all that good, but then you have got to make it good by compromising with situations, by understanding each other's problem, not just breaking up like ionic bond, just little bit of water added into it with high dielectric constant, and this breaks. All right, so no, or don't even be hydrogen bond that I explained in my previous, where hydrogen bond more interested in other. All right, so we saw there how C double bond O gets H gets electrostatic attraction. So please don't try to be hydrogen bond either. That also is very dangerous in life. So that's what happens today. That's what I hear. It happens, your relationship is going on well, marriage is going on, all of a sudden you get that hydrogen bond stuff and you're attracted by somebody else, and there's a disturbance over here. All right, fine. So with this note, I hope you enjoyed it. It was just my view. May take it or may just leave it. Well, that was my view. I just felt like sharing with you all. I enjoyed sharing it. Hope you enjoyed watching it. See you again in my next video. Bye.